Hey everyone, welcome to day one of this quick walkthrough on how to unlock the abilities of large language models like GPT using code. I'm Alex, a co-founder at AI Camp. We're an educational and professional program where students solve real problems using machine learning, just like you'll be doing today. This is going to be a short but jam-packed course. We'll be going over how these models work, how you can change and use them, and where you can keep looking for information when we're done with this quick intro. If you're 13 and up and want to join our community building with tools like these, check out AI Camp on our website or social media. We reserve 10% of all of our seats for scholarships focused on diversity and inclusion. So there's no risk in applying at aicamp.org/scholarship. All right, let's get right into it. This course is designed for developers looking to start building foundational skills in natural language processing. We're going to introduce transformers, what they are, and how to use them to do things like text generation and summarization. We'll start implementing GPT-2, a free and open source one, before getting into newer state-of-the-art models like GPT-3 and Flan T5. We're going to be implementing a few models because it's important to understand there are different options. These models have their own pros, cons, and unique parameters to change, but share a common architecture. As progress continues to be made in this field, there are going to be many new models released. Being comfortable reading documentation and published papers is so much more important than just knowing how to implement a specific model. That way, when new models come out, we'll know how to integrate them into our existing workflow and be able to understand their new capabilities. Recognizing and applying those net new capabilities is a huge area of opportunity. So getting started, today's key concepts: using APIs and transformers, what they are and how they work. Today, we're going to learn how to make a simple call to a GPT-2 model using Hugging Face's Inference API, and then how we can tweak it a bit. This is going to be a great foundation to build on and start developing our intuition. All the files you need can be found in the Files tab on the left of the screen and in the sidebar throughout this whole course. We'll also link to relevant sources throughout. We encourage you to keep these links open and come back to explore them further if they interest you. Getting comfortable with searching through documentations, white papers, example code, and then integrating them into your own work can really improve your capabilities as a developer. APIs. For those of you not familiar, an API is a way for two or more computer programs to communicate with each other programmatically or with code. This is really powerful because we can use APIs to automate tasks that would take us much longer to perform ourselves. There's a quick video explanation on how they work if you'd like a refresher. For this course, we're going to implement GPT-2 by leveraging the Hugging Face Inference API. The model file for GPT-2 large is over 3 gigabytes. Currently too large to fit in our REPL and many other devices. But this API lets us send requests to the model hosted on Hugging Face's servers. It will perform inference there or calculations given our input and send us back the output so that we can use it here on our REPL, or you could do the same on another device. There's documentation here for the Hugging Face Inference API attached, so you can learn a little bit more about it, organizations who use it, tasks solved with it, and how it works. Hugging Face is a community and data science platform that provides tools for building, training, and deploying machine learning models, and are pushing forward a lot of really cutting-edge AI machine learning developments currently. Really interesting organization. In order to be able to access the Hugging Face API, you'll have to create an account and your own API token. To do that, you can follow the steps below. We'll go ahead and go to huggingface.co, where if you haven't created an account, you should be able to do so in the top right corner. Because I'm already signed in, I'll go ahead and go to Settings, Access Tokens, and create a new token here that I'll name GPT Testing. I'll leave it as a read token, not a write token, because it only needs to read information from Hugging Face back to where I'm accessing it. I don't need to write anything to my Hugging Face account or save anything to it with this tool. So I'm going to opt to keep lower permissions and only let this token read access. Now that I have the token created, I'm going to go ahead and copy it to my clipboard and come back to our REPL. Now, there are better ways to manage these API keys because you don't want your API key shared with other people. In order to get into it a little bit quicker, today we're just going to save it to our main.py file as a variable. Great. Now that we've got it here, we'll keep moving. Next, what is a transformer and how to use them? Most large language models are based on the transformer architecture. Transformers were introduced by the Google Brain team in a famous paper from 2017 called Attention is All You Need. Now, a quick sidebar here, diving into research papers. Many of them are posted here on archive.org, and I know it can get a little bit scary looking at a site like this that might look really tough to navigate, or even when you click into the PDF and looking at the paper, it may seem intimidating because of how long it is and how unapproachable these big blocks of text can be. But I promise you, you can get really valuable information from these papers. Especially now, many machine learning updates and breakthroughs are shared in this format. I really encourage you to, when you're looking through these, to at least do a few things. You can check out the abstract, which is usually a pretty understandable high-level overview of the paper. Here we can see that a new concept is proposed called the transformer. There are a few different experiments, including English to German, which improved over the existing best results, and English to French, where they saw a new single model state-of-the-art score. Great. We also can see that it generalizes well to other tasks. Usually when I'm looking through papers like this, I'll look at the abstract, and if I can't get too much out of the middle parts, focus on the images and charts as they often describe the process well. And then at the end, there's a conclusion that often speaks the takeaways of the paper in a very clear fashion. So in this case, you can see that we presented the transformer. It is really great for translation tasks. They're excited about the future of it and plan to apply it to others. And the code that they used to train and evaluate their model was shared below, which is very common. Going back to our REPL, you can think of transformers as a new state-of-the-art way for computers to understand language, or any sequential information for that matter. But language is a key use case. I won't dive too deep into how they work, but there are a lot of great quality explanations for these fascinating tools online, on YouTube, or elsewhere. One great example is the illustrated transformer, which is a great visual walkthrough. You can see one pictured below, where there's information encoded into this model, and then that information is decoded and a new output presented. Hugging Face is maybe most famous for its Transformers library, which makes downloading and training these models extremely accessible. It has hundreds of models supported, and they're across natural language processing tasks, but also computer vision, audio, and other modalities. If you're interested, definitely check out some of these transformers. Today, we're going to be using GPT-2 Large. There are other model sizes, small, medium, large, extra large, but for this tutorial, we're going to be using GPT-2 Large. Before you head over to the next page, I'd encourage you to pause here and try implementing GPT-2 in your main.py on your own. There's all the instructions you need across the links that we've opened so far, specifically this page with GPT-2 Large, the Transformers library, and the Inference API, though you may have to go check out the documentation. I'll pause here while you give that a shot. All right. You may have tried to load the GPT-2 Large model via the Transformers library, as described on the GPT-2 Large page right here. From Transformers, you may have tried to import this pipeline where you could have used model GPT-2 Large as the text generation model that you wanted for this pipeline. If your machine was big enough to store this whole model, that would have worked. Unfortunately, here on Replit, we don't have the space. That's okay. We can use the free rate-limited inference API to call the model directly. When you come in and check out the inference API documentation, you can look at the detailed parameters section. And here we're looking at task generation. And you can see an example request. We could do this example using the requests library, but another solution is you can just import the inference API library from Hugging Face Hub and use inference that way. So if we went ahead and just copied this code and put it in here, I'm going to go ahead and rename my variable to API token. This gives us an endpoint here, inference, that we can call for text generation if we pass in an input string. Again, looking at the detailed parameters, it tells us which inputs are required. Inputs. A string to be generated from is the required parameter here. There are others that we'll be investigating a few of in a little bit, but for now, all we need is inputs defined. In our case, we're going to go ahead and define that as whatever string you'd like to have generated on top of. But in my case, I'm going to go ahead and say, learn about AI because have my result equal to an inference on that input string and go ahead and print it. When I run that, I'm going to go ahead and get a result. We've got output. Great. Learn about AI because you need to understand what it is when it's being applied to our lives, Dyson said. To that end, it has the ability to help us do things we used to have no power at all to do. Interesting. Try this out a few times. See if you're happy with the results that you're getting. Switch up this input string. Go ahead and try that now. You may have noticed that your model's performance was a little bit lacking. Machine learning models can work pretty well out of the box, but to get it from good to great, you often have to dive a little bit deeper. Being able to understand how your model works and dive into the documentation and the code, you'll be able to find functions or parameters or other features that you could tweak and change to improve performance for your own specific use case. We're going to go ahead and do that right now. Transformers have two distinct stages, encoding and decoding. Encoding is the first process where it takes text input, converts it to a numeric representation so it can use that. You can think of it like a learning stage where our model takes the text input and turns it into something it can understand. After the text has been encoded, the decoding stage begins. This is where the model uses its learnings and the input and returns a prediction. In this case, the prediction is just one word the model thinks should come next. Can you believe that all these capabilities from these GPT models are coming just from predicting the next word given some text? That's crazy to me. In order to improve our model's performance, we're going to focus on the decoding stage today. Three popular decoding methods are the deterministic method, stochastic, and a new development called contrastive search. Hugging Face recently released a blog post about this in November, covering it in much more detail. We're going to stick to the high level today, but I'd encourage you to check it out. Deterministic methods are typically the default, and they're actually what we have implemented. This method picks the words with the highest probability of appearing given a prefixed text. Although this method delivers consistent results, in practice, the generated output's prone to repetition and can get stuck in loops if the same words are predicted as most likely after each other repeatedly. That'll get you stuck in a loop. Stochastic methods were developed to try and combat this. Unlike deterministic methods, they use a little bit more randomness when picking the next word. It's much more hit or miss, and the output can quickly change topics, but it's an interesting approach. Two widely used methods are top K and top P sampling. We can use those by changing a few parameters. Those parameters, you guessed it, were top P and top K. When we were looking at those detailed parameters in the text generation task section of the inference API, looking at these parameters, we put in the input, but we see here that top K and P are other parameters we can change and what they modify here. we're going to go ahead and take some of the parameters suggested in this Hugging Face blog post and apply them to our model here. So we'll go ahead and create a section in our code for define our parameters, and we're going to put them there. I'll pause here to give you a second to try and see if you can get those working with our model right now. Hopefully you got that working on your own, but if you need a little bit of help, all we've got to do is include that in our call to the inference API. So in this case, if we wanted to create a new result with our top P parameters, we could just pass in top P params along with our input string to our inference and say we wanted to print a little bit of a different message to make sure we could see it. Top P. We could create a formatted string, just like so, with our result included. If we did the same for our top K params, we should be able to see all three of these, giving us different responses to the same query. Great. Here we can see the original deterministic method and compare it with our top P and top K methods. How do you think they compare? Moving one step further, we've got contrastive search. Contrastive search is the newest discovery. It picks the word that has the highest probability of appearing, but is least like the words in the prefix text. By doing this, we can make sure that we're producing text that's not repetitive, grammatically correct, and coherent. To implement this, it's a little bit of a mix between the two we had prior. We'll go ahead and drop it into our parameters section and generate a result where we're taking in our contrasted params and change what we print out when looking at it. Just like that, we can run with a new set of parameters and see a new set of output. Our contrastive search output was learn about AI because of the way we think. We think about the human mind as the most powerful computer in the world. We have to think about it that way because we're the ones that created it, and goes on. Since the contrastive search output is really high quality, we might want to use this for most of our tasks going forward, but not always. Changing these parameters is referred to as hyperparameter optimization. And parameter optimization, it's its own field within machine learning, but we went through this so that you're never afraid to look at how these tools work under the hood. Now you've got experience. When you're going in, diving deeper, and blazing your own trail, that's when the real learning happens. All right, so today, in day one, we learned what an API was and how to use the Hugging Face inference one. We learned what transformers were and how they worked, and then implemented GPT-2 large using that inference API. We then dove deeper into the documentation to eke out performance improvements. Now, looking ahead to day two, some things to think about. Right now, our user interface is just using code, typing into our existing Python file. Why is the user interface, do you think, important when working with these machine learning models? What ethical considerations are there when implementing large language models specifically? And how can we use text generation to solve other problems like text summarization? We'll cover these in the days to come, so make sure to keep continuing this course. If you're a teenager interested in joining a community that's solving problems with technology and exploring career options in tech, check out AI Camp. We have a 1 and 3 week camp, and we offer those to start, but exceptional students continue through our programs and join our Team Tomorrow. Team Tomorrow members work after school and on weekends on paid internal and external projects throughout high school and into college, opening doors for their future. In fact, one of our TT members, Shreya Dave, a college freshman, helped create today's content. Big shout out to Shreya. I encourage you to, once you finish this, also share it. Share it on social media or share it to your friends. Sharing the work that you've put in and the learnings you've received from that is really powerful for motivation and helps those learnings sink in a little bit deeper when teaching people. Looking forward to seeing you tomorrow. Take care. Bye.